So here we have my DIY weather station, which I've been working on for a few weeks now, and it's coming on pretty well. We have got cheap proprietary sensors here. We've got a tipping bucket rain gauge. If I just take its lid off, you can see there's a tipping bucket here, which fills up with rain one side, then it tips and empties and it falls down and starts filling up the other side again. We have and that just generates pulses from a reed switch. We have a rotating vane anemometer, which again is generating pulses from a reed switch and a magnet. And here we have a wind vane for wind direction. So it'll end up with the point facing upwind and the vane facing downwind. And this again has reed switches and a magnet in it. And it has a different resistor in series with each of the reed switches, so it gives you a different resistance for every 45-degree angle. The wires from these three sensors are going into this box here, which also has a photocell on the top to measure light levels. You can just see the photocell there. They're going to all come down from the roof. I've got a sort of TV aerial pole. I'm also going to put a bit of plastic conduit up from here with a horizontal bar with some bird spikes on it, because some of these things, particularly the anemometer, feels quite fragile. If a seagull lands on it, it could break it. Then we've got about 8 meters of Ethernet cables, Cat6 cable, 2 of those coming down. And also I'm going to have going directly through the wall from where it's mounted over here, I'm going to have this box which has got a BME 280 temperature, pressure and humidity sensor in it. And because that's running on I2C, the cable run needs to be kept pretty short, so it's going straight through the wall to a wall socket and then on into here. And this has all got the final cable lengths in, so that I know it's all going to work. Here we've got the base station. There's no sort of Ethernet connectivity. It's all just this 320 by 240 TFT touchscreen. I'm not actually using the touch facility on it. I had this in stock. It's actually a shield for an Arduino Uno, but I've just mounted it in there. And I'm using as my Arduino board this Mega 2560 Pro, which is a small version of the Arduino Mega with a standard pin spacing. But I just wire wrap to the pins and then solder it for belt and braces. So I've strapped across to the TFT shield. I did get a bit confused because it said which pins were used, but actually they're using the ICSP socket for quite a few of the connections. It uses SPI for the screen and a TF card slot on there. And you have to do jumpers on the back of the PCB. You have to solder across jumpers to connect across to the normal pins that will connect to the Uno. I think they've used the ICSP, so it's not board dependent. So it'll work on a Mega as well as an Uno if you use it as a shield, which obviously has different pins for the SPI. What else we got in there? We've got a real-time clock module on the I2C and another BME 280. So the one in the external box has had its jumper put on it to change its address from 76 to 77. Most of the sensors I had about 8 of them in stock, and I think 6 of them the jumpers didn't work because the PCB traces are wrong. They've sort of copied the idea of having the pads which you can solder across to change the address, but they've got the layout wrong and it doesn't actually work on most of the boards you seem to be able to purchase now. So I was lucky I had one old one in stock which did work, but I was wondering why on earth it wasn't changing address and stopping responding when I did the jumpering. Then we have this thing, an LTC4311, I think that's Adafruit, which is an I2C active terminator for improving I2C over long cable runs, and they say you should put it at the Arduino end of things, and it all seems to work. Actually, it works without it, but I've put it in sort of belt and braces. What else we got on here? We've got 4 push buttons and 2 LEDs, and then we've got a power socket and 15-pin D for the external sensors. So my 4 buttons, right, the right hand one is labelled backlight, and there's a pin on the TFT shield which you can jumper in to make the backlight controllable, and you can actually wire that to a pulse width modulated digital pin which lets you change the brightness as well. So I've lowered the brightness from its maximum, which should lengthen the lifetime of the LEDs. So if I press the backlight button quickly, it lights up the backlight, and that will stay on for 30 seconds now. If you want a longer backlight timeout, if you hold the button down, you get this little yellow asterisk in the bottom left corner of the screen, which means it's got the long backlight timeout now, which is 5 minutes. So my standard layout is to have a yellow title along the top, the date and time from the real-time clock up there, and then I've got 3 text screens and 9 graphical screens, 1 for each sensor. So this is just a bit of a diagnostic for my software version, whether the clock, the 2 BME 280s and the TF card have been detected. Then it's got the size of the 2 files I'm writing to the TF card. The int file is just used internally by the program and read back in. So this lets, after a power off, it can retrieve the data it needs for redrawing the graph. The CSV file is more for your own use, so it's better formatted, and that file is appended to, so it just is an infinite length up into the size of the card, I guess. And then I'm reporting the free RAM bytes just to check I haven't got any memory leaks really. The TF card, you can press this button here and you get a green LED. Now that stops any reading or writing from the card, so if you wanted to swap out the card or retrieve your data without worrying about whether it's going to get written to, you can do that. And then you press it again to toggle that off. If there isn't a card in, it will also light up green, and then you can't override it. The red LED tells you when the card's being read or written. Then we've got this display button. This cycles around the 13 different displays I've got. So as I said, there's 9, 1 for each sensor. So we've got rainfall, not very interesting because it hasn't been outside yet. I've just been randomly tipping it occasionally. And I've drawn this all just by hand using the line and pixel commands and the text commands. And the graphs are all based on, I store the minimum X and Y and the maximum X and Y and just calculate everything from that really. So we've got what other sensors we've got? We've got the wind speed, again that hasn't been doing anything in here. Wind direction, a bit of a mess because I didn't have the external sensors connected for a long time, so it was floating to a different value. External temperature. Now the reason these graphs are gappy is because whenever you power it on, because I'm not using the real-time clock for the graph, so I'm just using it for the CSV file, it puts a day-long gap in the graph to show there's been a discontinuity, and I've just been randomly uploading new sketches to get rid of bugs and test things and improve things. So external temperature, and as you can see all these are on a fixed scale, they're not dynamically scaling the y-axis. External humidity, I think something weird happened there when I was testing. External light, again this hasn't really been doing anything, that's just been where was floating with no sensor when it's been up there. I've got a op amp in the light circuits as photodiode and an op amp to amplify up the signal a bit. External pressure, you can see a bit more of a trend here, which is perhaps time to show you the other button, which is called style. Now this is the best sort of graph I've come up with, where it plots lines between the pixels, and so the line actually is very short because the X scale is 1 pixel per hour, so there should always be, each data point, unless you've got a gap, is 1 pixel on from each other. But obviously with something that varies quite rapidly, you can have quite a variation vertically from one data point to the next, and drawing a line between them gives you quite a nice filled in curve. Whereas what I started with was this, I was just drawing the pixels, which looks a bit rough, particularly on things that might jump up and down, like rainfall, for instance. So I think the line is a good compromise. But before I did that, I also experimented with a drawing rectangles up from the x-axis. I think if I was starting again, I'd just have it on the line all the time. Right, so what other sensors have we got on here then? We've got internal temperature. I've got less of a scale for that than, less wide scale than from external temperature. Internal humidity. Then this is this hour, so it basically takes an average of all the sensor readings over an hour. I think it samples the sensors about every 5 seconds and averages them over the hour. So this is the cumulative average for this hour, and for rainfall and wind speed it's extrapolated up to a whole hour. It tells you how many samples it's taken in the hour at the bottom there. And then my final text display is latest readings, and this was really another test thing to test some of the A to D values with these long cable runs and see if it made any difference. So I've got the raw rain tips in the last hour, how that translates to depth of rain, again wind speed, number of revs, wind direction as the ADC value on the analog input and translated to a bearing in degrees. Then the others are just the instantaneous readings of everything else. And then we're back round to the one I started on the diagnostic screen. The only thing I haven't shown you is the setup menu, which you do by holding down the style button. And that starts off the setup. So you can toggle around what sort of graph type you want by default. Then if you leave it for a while, it will go on to the next menu. Then I've got some offsets applied to the different sensors. I don't know why the BME 280, some of the temperatures are a bit weird and need a quite big offset on them, and certainly the one of the humidities as well. But you can change those to account for any discrepancies. And then finally, it lets you set the real-time clock, which is really the main reason for having the setup mode, is to have some way of setting the clock without loading different sketches to do it. So if you said yes there, it will ask you for the year, etc. So I think that's about it. I'll probably come back to that in a later video, and also in due course I will upload the sketch to my website and put a link in the description. But that's it for now. Thanks for watching.